I'm Mark from FRAMECAD, and we're just going to put some commercial context as to why the development you do is so incredibly important. You know, the industry is going through a lot of change, and it's trying to modernise itself because it's grossly unproductive. And everyone you talk to today is talking about how they're going to digitise the construction industry. And the outcome of that really is the construction industry is terribly inefficient and unproductive. So the objective is how, as visionaries and as commercial people and as technicians, do we help the industry go forward? And so there's a lot of talk about BIM, and really BIM's a way of changing the way we work and bringing much more collaboration at the start of projects. So people think about projects in the conceptual stage of how it's going to be designed, manufactured, coordinated, and how the communication and collaboration is going to happen in that project. And vital to that is that every aspect of the project is resolved in absolute 3D detail. So when the jigsaw puzzle comes together, we know all the parts are going to fit from the outset. And key to that is the ability to design in great detail and be able to transfer from architectural intent to design for manufacturing. A part of the problem there is the level of detail an architect thinks in is substantially different from the person who's actually got to manufacture the product. Architects maybe tend to think in a grand scale, whereas when you're manufacturing, you're thinking down to 0.5 millimetre and the precision that requires. And inherently in the platforms out there, architectural intent isn't really desiring to resolve the type of detail that a manufacturer needs to resolve. And the process is quite complex when you go from design to engineering through to manufacturing and the on-site practices. And inherently, no software is going to do it all. And that's why the work that the ODA and IntelliCAD is doing is so important, because we're creating the way that we can share information between different packages. And our success is based on how efficient we are at sharing information between different packages and then progressing that so that information progressively is starting to be delivered on a cloud platform. And unless we're thinking of that now, then we'll be irrelevant in 5 years' time. But yeah, I congratulate the work that ODA is doing now, because the movement towards BIM, Revit, IFC, those are actually mandated now in many of the countries we're dealing with. And unless we can do it, we'll become irrelevant in the marketplace. So some of these projects done around the world, this is one of our customers in UAE, and they're doing work in UAE and in Saudi Arabia and also into India. So these projects often now are being designed in 3D. Things like bathroom pods have been designed down to a detail in SolidWorks, and then that project gets exported off overseas, and when all the parts arrive on site, each part has to fit together perfectly. So we have this whole collaborative 3D world now, where parts will be made in different parts of the world, and when they arrive at a project, the project has to fit together perfectly. It also means that there's many different types of software being used, and so our ability to share information across different packages is essential to actually being material in the world today. This example here, that's they're doing 5,000 of those houses. They're going to manufacture them in UAE and export them to Saudi Arabia. Some of the bathroom pod projects, they might be doing 2,000 bathroom pods in a project. So when you're doing 2,000, it's pretty important to get right. Also, a lot of these companies are quite multinational now. So, you know, this company is a client of ours. They're working in UAE, Malaysia, and Saudi Arabia. And what's starting to happen around the world now, in countries like Singapore, they're mandating that projects have to be done in a BIM manner. And so it's not only a customer choice, it's now a government mandate that we need to change the way we design. We need to think about how we improve productivity. We need to think about the congestion in Singapore, that you can't actually do everything at the construction site. It needs to be designed in BIM, and the parts are made off-site. And the style of buildings we have to be able to design for everything from 10-level residential through to industrial, and we need to create all the design processes that can work across all those different platforms, different environments, different languages, and the localization that's required with that. And globally at the moment, politically, in most countries, there's a housing shortage. And so there's pressure now, how we find smarter ways to design, smarter ways to manufacture off-site, and how we can deliver housing to a high quality, better energy efficiency, plus deliver it faster. And so this is where 3D design, scalable manufacturing, and smarter ways of doing things and taking the inefficiency out of the industry are critical. And one of the biggest inefficiencies in the industry is actually understanding which parts are turning up when. And that's why, in terms of 3D design, it's not only the design process, it's the visibility on the manufacturing process, and it's actually understanding how to communicate, and everyone who's involved in the project maybe has got visibility on the model. So the trend now is that projects are starting to become model-driven. It's not just a set of plans. Everyone has visibility on the model, and how is the model coming together, and the owner, the project managers, the contractors have real visibility on the BIM model as it is manufactured and as it comes together on site. There's a little project that Rob did in Australia. He designed himself, so I'll let Rob talk to this little one.
This was basically 256 units that was built on top of an existing shopping centre. And part of the arrangement was we could not interrupt the trade of a shopping centre. We started doing this job on the first week in February, and we walked off site in the middle of June with 256 units erected, and all a variety of levels of finish. But the whole job was basically complete within 12 months.
Also, these jobs where we're overbuilding or working inside existing structures highlight the necessity now to have 3D scanning. So, scanning was sort of maybe in the past considered the realm of surveyors. Scanning's coming into mainstream construction very much now. So whether it's a renovation project or a new project, scanning and the ability to work with point clouds is actually part of core construction, and not just for surveyors or other people. So, we're talking before with ODA about all the different formats they can handle. For us to be able to handle point clouds and work with them comfortably and have smooth design processes, that's construction today. And unless we work efficiently and have smooth process, we won't be part of where the construction scene is in the world today. This is just another example from Australia. Again, the pod market is growing tremendously. Off Australia, UK, USA, more and more construction is being mandated to go off the construction site into factories. This is one of our clients' projects in Florida, USA. And what's happened in the USA in the last 5 years is most large projects, like 60 or 70%, are designed in Revit. And the Revit model is driving the project. So unless we're working in closely with Revit and being a part of that design process, we'll be excluded from being a part of the business. So the comment I made last year is if you're not in the model, you're not in the project. So the work with ODA and IntelliCAD are doing at the moment is so critical, because unless we fit smoothly into that process, we won't be in the business. As I mentioned, USA's probably gone 60% Revit. UK is now very strongly BIM and Revit orientated, and we have a situation where most large projects there, we have to work with that design process to be a part of the project. Singapore's mandated it. Australia's got quite a lot of Revit, but also a lot of ApplyCAD. So more and more, we have to fit in as a part of that design process. So the IFC work, Revit work, that's critical to our customers being successful. Also on these type of projects, again, indication of speed. On a lot of these large projects, we're doing one level per week in the manufacturing and erection project process. And then this is also from one of our customers in Vegas. They're manufacturing all the interior of this resort off-site. Stage 1 is 1,600 rooms, and they're manufacturing the frame, and all the boards are pre-cut. So it's basically a kit set approach to construction. So when you're doing a kit set approach to construction, understand exactly what you're delivering, having it all modelled up, and then having an efficient process to bring that jigsaw puzzle together. That's the first part of the challenge. The next part of the challenge is how do you manage all those parts coming together, right time, right place, printed the right way, arrow, install this way. And so it's a level of detail I start getting down to when you start looking at making buildings as a kit set. So to do that, yeah, we start with the CAD model, but then we have to think about actually how we create a cloud business model. Because it's not only design the parts, making them, but it's understanding the quality assurance process, and then tracking those parts physically with Q codes and understanding logistically where they're at in terms of the journey, so the right part turns up on the right day in the right place to make the job go smoothly. So, you know, to do that, we have a knowledge base. We make it available to our customers. We have detailed design information on how to do it. We're creating the estimating and quoting tools, training materials, that online business process that really starts being model driven, but ultimately comes down to tracking the real product on its journey to arriving at the right place in the job site at the right time. And across all that, we're managing real-time manufacturing plants. So integration's key. And, you know, we've heard some great things from ODA and from IntelliCAD, and the more we integrate, the better our lives will be, because we won't be disqualifying ourselves from joining the game. So integration in all formats to create smooth, easy, efficient workflows is absolutely vital. So, yeah, I think for the last 4 or 5 years, Dave's got sick of hearing me asking for Revit and IFC. But, you know, Dave's been also a great voice for IntelliCAD and pushing that with ODA as well. So, you know, congratulations for the progress that ODA's made in the last 2 years. Yeah, there's good momentum there. We probably needed it 4 years ago, but at least it's happening now, and it's vital to all our successes. So, you know, what are the drivers for technology? So, you know, what we see is that the old way of doing things in every part of the world is changing. You know, if we look at traditional methods for construction, they were very slow and efficient, often 65% wastage, 3 times longer than it should take. Globally, even in low-cost economies, you know, in China there's a shortage of skilled workers. In India, workers may be quite cheap, but the skill level is very low. You know, most people going to school these days aren't going to school to say I'm going to become a construction worker. So that means that always we're going to have a shortage of skilled workers. Yeah, obviously, Mr. Trump's trying to put a border up between Mexico and USA to keep the workers out. So USA probably has 250,000 shortage of construction workers. So that means we need to drive it towards automation. We need to drive the industry towards production in a factory. And also typically, you know, in the USA, a construction worker on site, fully costed, is $120 per hour by the time they pay insurance and workers' comp and all these different things. You know, same worker in a factory environment is $38 per hour. So that project we showed you before in Vegas, they worked out that they'd gone from 56 people on site down to 8 by prefabricating it, and saved $6 million in on-site labour. So when we've got those type of savings coming along, then there's a reason to do things differently. Also, the other good thing, you know, globally, materials shortage, like, you know, timber harvesting is no longer fashionable in Malaysia or Africa. Also, natural materials like timber have quality issues for consistency and typically have about 20% wastage. So, you know, for us, that's a means to change to more modern materials And surprisingly, in many parts of the world, like the Middle East, there's a shortage of sand to make cement, the right type of sand. So that's why we're having to think about different ways of doing things, because we can't assume the way we did it 5 years ago or 10 years ago is going to be relevant even next year. The other trend we see obviously is 3D, 4D, 5D, 6D. These are critical to actually have a modern method of designing and producing anything, whether it's a car or a house. But you need to have a whole ecosystem. Everyone's been saying BIM's coming for the last 15 years. The problem was when there's only a quarter of the people doing it, you can't do BIM, a project with only a quarter of the people being involved. What we're seeing now is both the practicality, that most software can actually share the information, and there's enough skilled people to be able to use it, and projects being mandated to use it. BIM's arrived now, and we have to be a part of that system. It's also notable in China. For the last 3 years, the government there's also mandated that projects should be done in BIM. At the moment, the challenge is if you ask 10 people what is BIM, you'll get at least 10 different answers. So there's a recognition that BIM is here. There's still not really a common understanding of what it is, and even less understanding of how to do it properly. The other thing which everyone thinks BIM is going to be all the design is done perfectly in 3D, and then the project goes together. Because we're still moving towards that, the simplest way now to actually capture a project is scanning technology's got so mobile and so fast and so efficient. At least you can go around a project these days, and within one day you can very accurately capture the whole as-built detail for that project, probably down to a precision of plus or minus 2 or 3 millimeters for the whole project. So even if BIM's not here, scanning is creating as-built capability. So if you're going to go into the managing the life cycle of a building, you can at least get a model of what you're managing. And then in terms of the digital ecosystem, everything's moving towards real-time visibility, real-time management. Everyone's got a smartphone, so the amount of information you can get on and off the cloud through a smartphone virtually puts all the information in the hands of anybody who you want to have authorised to use it. So moving to mobile and a lot of the stuff we've been seeing from ODA, all those things are very positive, and the world's going cloud, the world's going SaaS. We've just got to make sure that we're part of the game.
Okay, I'm going to give a very short presentation of actually using our software. Normally we get drawings supplied in DWG format, and I've got one such drawing on the screen in front of me. So what we normally do would be just draw over the top of it, basically trace it. I've already got it on a layer, so I can turn it on and off as I require. So there's my wall frames drawn in. This one here on the end's not quite square. Once I've drawn walls in, I can then come around and give them intelligence. I can set the heights, the widths, a whole heap of parameters. So there's our wall frame layout basically finished. I can then come along and put my windows in. We have a variety of settings. The software is very flexible. I can put my doors in. So there's my wall frame layout basically finished. And that is it fully done. So that the walls for this small building basically took me a few minutes. Then I can come and do my roof truss layout. Now I can add my roof trusses to the building. Once again, I have a variety of settings. There's my roof trusses finished, primarily engineered. And then I can look at them in 3D. If that was a realistic job, that would be finished. And that's what we've been able to do since we've been using IntelliCAD. I started doing this 30 odd years ago, and 30 odd years ago we'd done this on a drawing board, and that would have taken a week. Whereas these days we do it in literally 10, 15 minutes. Behind all of our trusses and behind all of our wall frames, we have pull engineering. That truss was engineered and designed in real time. The same with the wall frames. It's something our users basically take for granted. They don't have to be an engineer because it just happens. And I suppose that's the beauty of the software. Okay, so I think that's the end of our short presentation. Thank you.